So guys, we'll be solving this question today. This is a 1000 rated question. It is simple, but as always, not as always, but generally these 1000 rated questions have difficult implementation. Even if the logic is easy, implementing it is a bit tricky. So let's look at the question. Let's say Monocarp is playing another game. We need to kill the monster. There are n monsters. Monster has an AI health. Okay, so after that each hit k damage will be dealt. And how is the pattern? That the character has the ability that deals k damage to the monster with the highest current health. That means among all the monsters, the one which has the highest health, the damage is dealt to that monster. Okay, that is the pattern. And if there are several of them, that means if several have the same highest current health, the damage is dealt to the one with the smaller index. Now if it is 0 or negative, the health becomes 0 or negative, the monster dies. We need to find the pattern in which the monster dies, the order in which the monsters die. So let's take an example. So 2835, right? This is an example. And what's the damage? 3. So test case is that k, that is the damage dealt in each blow, in each attack, is 3, and the monster's health, the first monster, second, third, fourth, is 2, 3, 8, 5. So the first attack will be dealt to the monster which has the highest health among these 4 health points. So 8, right? This third monster. So this, I'll just write this as ID, index, and this as health points of that monster. So the first damage, the first blow by the character is done to monster 3. So if we subtract this, then it becomes 8 minus 3, which is 5. So I'll replace this with 5. Now among these all, the highest health points are for third and fourth monsters. Then if there are multiple with the same highest current health, then the lower index will receive the blow, right, according to the question. So yeah, the damage will be dealt to this. So this becomes again 5 minus 3, which is 2. Now the damage will be dealt to this monster because it has the highest health now. So again 5, 2. Now again this monster. So 3 minus 3 is 0. So this dies, right? This dies now. So we need to print the first monster that dies is monster 2. After that, all these monsters have same health. The lower index will receive the blow. So after receiving the blow, it will die. So next monster to die will be of index. The second monster will be the second monster to die will be the first monster index. Okay, don't get confused. Okay, so the third monster which will die is the monster with index 3, and the fourth will be the index 4. So 2, 1, 3, 4 should be the answer. Let us see. Sorry, 3, 1, 2, 4, right? Okay, 3. Just a minute. I did something wrong here. Okay, what is it? 2, 8, 3, 5. Oh, I did 2, 3, 8, 5. What? Okay, my bad. 2, 8, 3, 5. So the first damage will be done to him. This becomes 5. The second damage will be done to him. Then again this becomes 2, and then 0. No, once this becomes 2, just a second. Once this becomes 2, damage will be done to this. So this becomes 2, and then this dies. Okay, that's right. This one dies first, and then 1, then 3, and 2, and then 4. Did you understand what I did? Okay, my first attack is this to monster 2. So 8 becomes 5. My second, now these are the numbers. Now second attack will be again this monster. So it becomes 2. So these are the health points now. Okay, 2, 2, 2, 2, 3, 5. The highest is 5. So attack him. So it becomes 2. So again 2, 2, 3, 2. So now 3 will receive the attack, and once 3 will receive it, it will die. Okay, that's the okay. And again after this, 2 is left, right? So first index, then second index, then fourth index. It becomes -1, -1, -1, which means it dies in this order. So the order is 3 1 2 4. 3 1 2 4. That is the dry run, right? So what is this? This is a greedy way, right? This is not a greedy. This is an optimized way, because we are already told what to do to attack the monster which has the highest health. Recursively, okay? We'll attack and then we'll again check whose health point is maximum, and then we'll attack that monster. So this is an optimized, not a structured answer, okay? So we are told what to do. So we can do it like that we'll sort this array according to the hit points. We'll sort it according to the hit points, and then we'll attack the one with the highest hit points, and we'll do it again and again till it dies, and after it dies we'll note down the index. That is one of the methods. But as you can look at the constraints, there are number of monsters are 3 into 10 to the power 5, and each monster may have health 1 to 10 to the power 9, and K, the attack, the damage the monster receives is from 1 to 10 to the power 9. So in the worst case, the operations will be 3 into 10 to the power 5 times 10 to the power 9, that is 3 into 10 to the power 14, and there's again some sorting required, right? These are the number of operations, and again in these operations we need to add sorting, so it will definitely exceed 2 seconds. So the brute force way is not the correct way, okay? Now there's an observation here. What we are doing is that among all the monsters which have hit points, just a second, I'll erase all of this. So among all these monsters, what I'm doing is I'm attacking the one which has maximum health. So this gets reduced, then again this gets reduced. That means all the high values gets reduced first, and till where does it come? Okay, once all the values are, let's say, come to the minimum it can be, after that attacking will only kill that monster, right? That means, just imagine this. So what we did here was we reduced all of these to 2, 2, 3, 2, and after this, what is this? This is, as you can observe, we are reducing all the values till just till the value after which, okay, let me rephrase. For all the monsters, we are using n number of these operations, n number of these attacks. What happens is that each monster comes to a health, and what is something significant about this health, that if we attack that monster it will die directly. We bring this all to one hit only, just one hit. Now just one hit can kill all the monsters. We bring all these monsters health to one hit. That is what we are doing using all these operations. It is an observation, it is not mentioned here, it is the observation we did, okay? Imagine if it was 777, just a minute, 773, okay, and each damage deals 2 attack. So what will happen? The first will reduce this, so it becomes 573, then again 553, then 353, then 333, then once it becomes 333 it becomes 133, then 113, and then 111. See, with any health we bring it down till it becomes one hit, and once it becomes one hit we directly kill it. So after it becomes 0 1 1 0 0 1, and then 0 0 0, sorry, not 0, all these are -1 because we are dealing 2 as attack, right? K is equal to 2. It becomes -1 -1 -1 These are the health points. I'm taking a health point, another case of health points. So as you can observe, we are bringing all the healths down to them being just one hit away from death. and after that we are killing them. So what is this? This is nothing but the remainder, right? Once we mod it by k, once we divide it by k, the remainder is what being one hit away means, right? So any health point, what it will be? It will be some multiple of k plus a remainder. So to bring it to one hit, as remainder, this remainder will be less than k. That means at last we transform this health point as r, the only remainder. From this, all this, we deliver m attacks and bring it down to r health points. So one hit will kill it now. So when we attack this, it will die. Okay, so that was the concept, and to implement this we'll use array list. Okay, why? Because we need index also, right? There are two data and they are intertwined. Like just in the day before yesterday's question, there were two interlinked data types, right? In here it is the health points. Each monster has health points and a particular index, the position we need to, finally we need to output the positions of the monster which die in order, right? We need to print it. So the positions of the initial positions of the monsters matter and their health points matter. So these two values matter and they are intertwined. That means for each position there is a particular health point, right? So again, like before, we need to use, I'll show you the implementation. Just a second. So I created a class M that is a blueprint of a monster. That monster will have two properties: the index, that is the position, and the health points. And we write a constructor here. What is a constructor? Constructor initializes the values of the objects. That means this is the class is a blueprint of an object. So I'm creating a blueprint. That means it has properties this and this. This is what we do in class. We just define the properties, and then when we actually create an object of this class, when I create an object of this class, I need to pass the values, right? I need it to store values, and to store it values, that means to initialize the object, this constructor is used. This is a constructor. It has no return data type and it just initializes the object. So this dot id means when we call this constructor, that new object with property id has a value of a which will be passed. This parameter a will be given to the property id of this new object when we call it. So that's what I've done here. I have accepted this and I created an array list of monster data of this monster objects. So a monster object has index, that is the position, and health points, these two properties. And I have created an array list of this monster data type that I have created, new monster object. So after I did that, instead of in the health points, what does health point mean? Health points, as I stated in this observation, we bring every health point down to just them being one hit away, right? Them being one hit away. So that is directly mod, right? The health points mod k. But you need to note down that if it is a multiple of k, that means let's say there's another health point 8 and k is equal to 2. In this case, what happens is that it does not come down to 0. It directly doesn't kill it. Let me show you. Yeah, you can say that it is directly killing this. That means them being okay. I'll explain this again. Okay, just take this as 7. Okay, so 7, 3, 8. Let's say these are the three health point values and k is 2. So what happens? First this 8 gets reduced, so then again 5, 3, 6, then again 5, 3, 4, then 3, 3, 4, then 3, 3, 2, then 1, 3, 2, then 1, 1, 2. So again the point is correct that they are being leveled down to, that means they are being damaged till they are one hit, but the first one it dies, right? So it becomes 110. So every monster which has mod k as 0, that means it is a multiple of k, they die first, and this becomes 0 1 0, then sorry, minus 1 1 0, then minus 1 0. So all the monsters have died. The first one to die is the monster 3, then monster 1, and then monster 2 dies. This is the order that they die in. So as you can see, what does that mean? Okay, just remember. Okay, I'll take this case again. Okay, I'll later refer to this case. Let's say I arrange them in order of their mod, right? So let's say k is equal to 5, and after I mod the values, let's say h hit points, right? So let's say hit points were some a1 a2 a3, and after modding them with 5, mod 5 mod 5 and mod 5, let's say the values come out to be 3 to 5. These are the values, right? So not 3 to 5, 5 cannot come as a mod, just a second, 3 to 4, let's say. So in what happens here, in 3 to 4, when the hit points become 3 to 4, all of them are one hit away, right? One hit away. So what is the next operation? The highest health value will receive the hit and this will die. That means this dies first, then this one dies, then this one dies. So the greatest health points dies first. So if we arrange them in decreasing order of the hit points, mod of hit points, right? Mod of hit points. If we arrange them in decreasing order of mod of hit points, then that is the order in which they die. So this one will die first, this element will die next, then this. Got it? But we just notice that when it is a multiple of k, the mod becomes 0 directly. But they don't die at last, they die at first. These multiples are the ones which die first, and after that the other monster dies which have some remainder left. So to debug this, we'll just make them as the first ones in this order. So when in decreasing order, we'll make all the elements that are 0 as first. And how can we do that? As these are remainders of HP, right? These are remainders, we do mod of HP. So all these value can never be greater than the value itself. Like what I mean to say is, just a second, let's say there are two numbers, right? A and B. So if we do A mod B and it comes out to be C, so in this case A is what? Hit points. B is what? The K, the damage being dealt. What is C? C is the modified hit points that I'm storing. Modified hit points. So this modified hit points can never be, as A mod B is equal to C, we know a property that C is less than A and C is also less than B, right? So we know this. So we'll directly say that let's put all this modified, the ones which are multiples, we need all the multiples to beginning of the list, right? We sort it in decreasing order, and we need all the we sort them in decreasing order. Let's say the multiples are 5, k is equal to 7 in this case, and the modified hit points, that when we do hit points mod k, it becomes 5 2 0 0 3 6 1. Let's say this is an example I'm taking. So what we'll do, we'll sort them in decreasing order. We'll sort them because that is what the pattern in which they die, right? According to our observation, we'll sort them 6 5 3 2 1 0 0. So this is correct, that this is the order in which they die, that this element, this monster, let me write the indexes as well: monster 1, monster 2, monster 3, monster 4, monster 5, monster 6 and monster 7. So this becomes monster 6, monster 1, monster, what is 3 5, monster 2, monster 7, monster 3, monster 4. So we are right that in this order the sixth monster dies before monster 1, because this among after they come to one hit, being one hit, this one will be attacked, right, because this has the greatest high point. So in decreasing order, that is correct. But what we notice is that the multiples, that means when the remainder is 0, these monster die first, so we need these monster to come before this, and all these values, all these modified HP values, these all values are less than k always, because that's what we stated, HP mod k, that is what the modified HP values are. So all these will be less than k. So what we'll do is we'll just add k to them, so these directly, when we sort them, these all elements directly come here. So we'll just add k to all the elements which are 0, and once they become 0, all these come here, like 7, 6, 5, 3, 2, 1. So this was monster 3 comes here, monster 4 come here, monster 6, monster 1, monster 5, monster 2, monster 7, and this is correct. This is finally the order in which they die. Got it? So that's what the code says here, that I directly take values, that is the health points mod k, and if that modified health point is 0, I directly assign them a value of k, that so that when we sort them they come at first, or otherwise I just take the values of r, that is the modified HP value, and when we add an object, I'm directly passing, I have started from 0, so the position will be index plus 1, and r is the modified hit point. So I add an object in the array list, and I sort the array list according as, okay, this is the lambda function to sort it. And how we have sorted it? We have sorted it such that when the hit points are not equal, that means hit points, these hit points, when these hit points are not equal, let's say 6 and 5, what is this? This is a lambda function to compare, right? So how does comparing work? It works by taking 2 of the objects of A. So I'm sorting an array list A, and in array list A, the sort happens by repeated comparison of 2 objects of that array list. So 2 objects, let's say it was x and y. What is x and y? X are the 2 arbitrary objects of M. So to compare x and y, we need to tell it on which property do we need to compare, because M has 2 properties, HP and ID. So we tell it to compare it by HP, because that is what we need, right? We need it in decreasing order of health points, the modified health points. But also what we need is, we need that according to the question says that if there are equal hit points, then the monster at lesser index must get attacked first. So when the hit points are not equal, then we need to arrange them in decreasing order. This is what decreasing order looks like. You can look into the syntax, okay? I cannot explain it because it will take a lot of time, but just note that this is decreasing order. So if the hit points, if the 2 objects we are comparing have different hit points, then we arrange them in decreasing order. And if they have equal hit points, that means the other case, right? In the other case, we need to arrange it such that the ID, the lesser ID should come first. See here, it was y and x, that is decreasing order. X and y means increasing order. So all the elements will be arranged in such a way that these 2 conditions hold. Just a second. That the same hit points will be arranged in increasing order of index, and different hit points we need to arrange them in decreasing order of hit points. So example as 3, 5, 5, 2, 2, 6, right? And let's say this is hit points and this is position. So position is, let's say 5, how many elements are there? 6. So 6, 2, 3, 1, 4, 5. So how the sorting will work is that, or it will be arranged in decreasing order. So 6 will come first. So 6 and 4, the position 4th hit point 6 will come first. After that, these two are same, but in this same we arrange them in increasing order. So according to the position, so position 2 will come first. So 2, 5, 5, 6, then 3, 5, 2, 3, 2, 1. This is the final sorting that happens using that lambda function that I have used. Okay, and this is the order in which the monsters die. So finally we just need to print, after sorting them, we need to print out the IDs, because that is the final way in which we sort them. Okay, thank you guys.